Suppose we wanted to evaluate this integral, and suppose I want to evaluate it using what I call substitution by matching. These are the steps, and although it might look daunting on first glance, as you practice more and more, you'll get into the flow of it and see that it's really not bad at all. Before we get started, I want to go ahead and copy the problem back down again. Now, looking up at our steps, step 1 says that we need to let u be equal to the expression raised to the power. That, in this case, would be x minus 6. Step 2 says to compute du over dx. Du over dx would be 1. Step 3 says to solve for du. So I just multiply both sides by dx. And I find that du is equal to 1 dx, or just dx. Step 4 says, if the integrand has a numeric, which means a constant factor, move it outside the integral sign. Now there is a 2 here, which is a numeric factor. So I'm going to move it outside of the integral sign. Step 5 says, the integrand must be reconstructed so that the u part is followed by the du part. And remember, you can always compensate by a constant factor if you need it. You can put the constant factor inside the integrand and compensate by multiplying by its reciprocal on the outside. You're always allowed to do that. Here, we're also concentrating just on the integral part. The 2 just sits there. The 2 doesn't go away. It's going to be 2 times something. But we don't worry about the 2, we just carry it along for now. We're interested in the integral itself. So the u part is the part that's raised to the power. And when I say u part, I'm also including the exponent as well. So the u part is x minus 6 quantity raised to the 3/2 power. The du part is the rest of the integral. In other words, everything else to the right of the integral sign. And the only thing left inside the integral to the right of the integral sign is the dx. So that is the du part. It's everything else. Now keep in mind that 2 doesn't vanish. We don't do anything with it right now, but it just carries along. Step 6 tells us substitute for the u and the du. Now remember, the u part is the part associated with the x minus 6. So if we're actually going to do the substitution in the integral, the x minus 6 becomes the u to the 3/2 power. The u part followed by the du part, which we said was dx. The dx is du. And that's our substitution. Be careful to see what's happened. This is the u part. That corresponds to the u part in the original with x's in it. And this is the du part, which corresponds to the du part up here. So we've completely eliminated all the x's and dx's and replaced them with u's and du's, which is the goal. I'm going to rewrite that integral without all the clutter. I'm not changing anything, I'm just getting rid of some of the clutter. So I get the integral of u to the 3/2 du. And of course it's still multiplied by 2. Keep in mind that I'm doing this substitution so that I can fit the integral into the general power rule for integration, which tells me if I have an integral of the form u to the n, I can evaluate it by raising the power of n by 1 and compensating by multiplying by its reciprocal 1 over n plus 1. So, go up by 1, 3/2 plus 1. I hope I don't need to go through this, but I will. 1 is 2/2, so 3/2 plus 1 is 3/2 plus 2/2, which is 5/2. So by the general power rule for integration, the integral of u to the 3/2 is going to have a power of 5/2, but it's going to be multiplied out front by its reciprocal, 1 over 5/2. Now, I could write 1 over 5/2, but the reciprocal of a fraction is just the fraction turned upside down, so that would be 2/5. And don't ever forget the plus c, because we're doing an indefinite integral, and you always have to say plus c to allow for the possibility that there was a constant added in there or subtracted whose derivative is 0. There's no way to know, so you put the plus c. And of course, 2 times 2/5 is 4/5, so we end up with 4/5 u to the 5/2 plus c. We're done with the integration, but remember the problem didn't start out with u's in it, so we have to get rid of the u's by going back and remembering what u is. U is x minus 6, so we go back in and we write 4/5 times the quantity x minus 6 to the 5/2 power plus c. And there's your solution.